Hello everyone. This is an introduction to our paper, EgoPCA, a new framework for egocentric hand-object interaction understanding. This is our project page with our code and data. Understanding egocentric hand-object interactions, or EgoHOI, from first-person video is a key capability for embodied AI agents. There are large domain gap between egocentric and exocentric videos. Exocentric videos are objective and contain full human body and wider context, while egocentric videos are subjective and contain mainly human hands in limited FOV. However, most prior work relies on models and datasets for third-person action recognition, despite the large gap between egocentric and exocentric videos. So, how can we design effective models and training mechanisms specifically for learning EgoHOI? To answer this question, we propose EgoPCA. We first thoroughly probe and analyze the properties of egocentric videos. We apply data curation to propose balanced pre-train and test sets for the EgoHOI task. We then propose a baseline model with dual networks and custom constraints for EgoHOI. We train the model on the balanced pre-trained sets for all models and finally adapt the model to specific EgoHOI benchmarks. So, PCA stands for probing, curation, and adaptation. In detail, we first analyze the 6 key properties of EgoHOI videos, including semantics, camera motion, blurriness, hand object locations, and hand pose. We quantize the properties and represent the properties of each video clip as a vector. Then, we propose 2 sampling strategies based on the video property representations. In the first scenario, we sample videos in the low-density area in the dataspace for the balanced dataset. We build balanced pre-train and test sets called one for all P and one for all T for unbiased pre-training and fair benchmarking. In the second scenario, we sample videos that are similar to the existing ones to enhance the model performance. We use this strategy to adapt the model to specific test sets including Epic Kitchen's Ego 4D and so on. We also propose a one-for-all baseline model to solve multiple benchmarks in one model. The baseline has 2 visual encoders, light and heavy, to flexibly gain both performance and efficiency. We adopt video network MVIT as a heavy network and image level VIT with frame selector as a light network. The visual features are aligned with the text feature in the clip manner. Given the special properties of EgoHOI videos, we also design 2 auxiliary constraints. Serial visual scene attention requires the model to predict the future camera motion from previous frames. Counterfactual reasoning requires output change after causal intervention on the hand node. We pre-train the one-for-all model on the balanced dataset one for all P and also evaluate the balanced test set one for all T. Our model outperforms previous EgoHOI pre-train models. To adapt our pre-train model to the specific downstream tasks, we present the all-for-one mechanism. We first fine-tune the model to achieve comparable or SOTA on the current benchmarks, including Ego 4D, EGTEA, and Epic Kitchens. And based on our Ego property sampling, we replace part of the training set with some external informative videos. We enhance the EgoHOI learning performance with no computation overheads. That's all. If you are interested in our work, please scan this QR code of our project page for more information. Thank you.